this video, we are going to illustrate an incredibly interesting product, a truly unique product, namely a specialized two-component material that allows you to replicate almost any object with extreme precision and detail. Or at least we're talking about replicating the complex interior of an object. Specifically, those areas where it is exceptionally difficult for us to take accurate measurements manually. How can we accurately measure and analyze an internal part, especially when it comes to complex metal components? We're using the metallography process. Metallography allows us to section the piece, prepare it thoroughly, and then measure it using a precision optical system or other measurement methods. The system we want to propose is the use of a two-component material, a special two-component material that helps reduce waste and, of course, lower costs. And there is absolutely no material loss involved here, meaning that whenever we use a traditional destructive system, we unfortunately end up destroying the pieces and obviously cannot perform measurements on many different pieces, but only on a few or even on single samples. The system itself is quite simple. It consists of using specialized silicones, specifically two-component silicones, which are very effective materials for this process. And we have them in the case where we use the liquid versions. So in order to accurately reproduce or to make a detailed mold of the inside of an object, which can have various shapes, including threads or undercuts. And then we will also look at the application of the various two-component materials. We have three versions. We have a 60 Shore version that clearly allows us to detect. These can be internal surfaces, however, that do not have undercuts or threads inside, since it has a clearly higher hardness. We also have an intermediate version which features a Shore hardness of 35. This allows us to capture, for example, complex internal molds, perhaps even fine threads or undercuts, though not very pronounced ones. Then we have the highly flexible green version, which has a Shore hardness of 20, allowing us to perform precise measurements and inspections even on intricate parts, with, let's say, more intricate and complex features. Now let's get practical and make some molds. Let's start with the preparation. Preparation consists of clearly taking the part that we want, the one we want to work on, the mold. First, take a piece of adhesive tape and use it to carefully isolate the specific area, let's say the exact spot where we are going to work. Then you can proceed to pour in the contents, which is the two-component mixture we have ready. This design provides us with the capability, in addition to obviously being able to pour the contents smoothly, it also lets us have a specifically designed piece that enables us to much more easily and efficiently remove the entire mold structure as well. We also prepare a piece that has, let's say, more challenging features in terms of replication. So with a thread, in this case, we have a thread with a very fine pitch and an undercut. We prepare this as well. Now let's carefully begin the process of pouring the silicone. When using a brand new cartridge, we perform an initial pour. On a glass slide, we place a glass slide that also serves as a support plate. The specific part that we, as we might say, that extends well beyond the piece itself. Yes, also so that over time it allows us to penetrate as well. placed deep inside the piece model, arranged in such a way as to encompass every type. As we've seen, the product is very liquid, so it really allows it to adhere to all surfaces. Now we're going to begin working on the second component of the project. And for this other piece, we'll use a specialized two-part chemical product with, let's say, specific levels of hardness and physical characteristics that are quite different. In this particular case, we have a fresh and unused cartridge. So we allow the two components to mix, and then we can begin the application. The gluing inside the object. Now that we have finally finished, regarding the gluing process inside the samples, we need to wait for about 15 minutes, specifically 15 to 20 minutes, for the material to completely solidify and set. Clearly, the higher the hardness of the silicone being used, the faster the, let's say, overall drying speed. There is also another version available with a shore hardness of 95, which is a very high level of hardness, and this allows us to easily make replicas during the drying process. Faster replicas, even on parts that can be, for example, even a porosity specimen, reproducing even a porosity specimen in an extremely faithful way. We are talking about RA2, RA3 porosity specimens, which basically become something almost impossible to do. These products are products that allow any type of mechanical company or others to carry out inspections. Quality within their own production without having to resort to what is metallography and therefore the destruction of the parts. Now let us proceed with the extraction of the samples that we have taken, that we performed earlier, both in terms of external molds, therefore with the pastes, and in terms of the molds, that is the reproduction. The very first operation that you need to perform is to carefully peel away the adhesive tape, and once you have finished doing that, prepare to use a specific tool such as a rotating movement. The stretchability of this material, therefore the stress it can withstand, is extremely high. We can still apply a significant amount of tension without having to worry about breaking the material. As you can see right here, let's carefully remove the tape clearly from the end part, and as we can see, we have successfully reproduced the design. Even a thread with a pitch that is almost impossible to see in an incredibly precise and flawless way. Let's extract this one as well. The other one, once again, by peeling off the tape. Once we've removed the tape, we proceed to do the same operation as before by gently rocking it back and forth and carefully extracting the sample. We perform the simplest possible operation when it comes to handling the external molds. And so, at this point in the process, we can now proceed further with the actual measurement. To carry out the measurement effectively, we are going to use a stereo microscope with integrated measurement functions, which allows us to perform certain specialized tasks with ease. Let's say, for example, there are many different types of measurements that we can take on these specific items to ensure accuracy. We delete the previous measurements and proceed to perform. We can perform linear measurements. Additionally, we can also perform measurements such as, for instance, of the specific pitch, in this case of the thread. Pitch 0.50. We also have several other features available, such as precise angle measurement, but clearly this is limited to certain specific types of measurements. Depth measurements or 3D measurements must be performed using high-precision optical level equipment and specialized instruments. A different environment. One of the many different things that we can check, for example, besides just the dimensional aspect, is the quality. It is also the surface aspect and appearance. Therefore, with this type of two-component material, we are also able to accurately simulate and reproduce, for example, issues related to turning or any kind of surface imperfections. So we can have. These are high-level magnifications that allow us to view the surface in a truly detailed and comprehensive fashion. Here, for example, we have the external casts that we have carefully made for this study. And here too, we have the distinct opportunity to perform various precise linear measurements, dimensional ones, or measurements, for example, of circumferences. Where we are able to obtain the radius, the diameter, the circumference, and also the area. If we had multiple diameters, we can also check whether they are concentric. In the specific case of this measurement, clearly you can create detailed sections, always using the external cast that we previously made once we have carefully cut it with the cutter. And here too, we can carry out precise measurements of the pitch to ensure accuracy. Alternatively, you can obtain highly accurate linear measurements by slowly and steadily moving the object within the designated scanning area. For depth or various other types of measurements, with more advanced optical systems, for example in 3D mode, we are also able to obtain automatic measurements and shape recognition once certain parameters are set without having to use these types of systems manually. As for the illustration and also the system for extracting the pieces and the samples taken, we've covered everything. For any information about this product, you can go directly to our website, which is www.ARWMisure.it. Go to the section specifically dedicated to silicone components. And there you can find all the different types of items. We haven't covered them all, and we will look at the pastes in other videos as well. Because this specific piece of equipment right here is also suitable for taking precise measurements of external molds. It is important to note that we can make these external molds to inspect the surface for any potential imperfections or even to take detailed measurements. Of course, if we have a piece like this one, we can proceed directly to the optical system and carry out the measurement. However, in some cases where we have very large parts or when we want to examine specific details, grooves or threads, we make a mold directly using these pastes here and then proceed to measure them. Or, for example, in the field of mechanics, during turning operations, we have parts that are mounted on the machine and cannot be moved because that would cause the piece to become misaligned. In this way, we can use this particular product to take a mold and then measure it without having to move the part. As I mentioned, you can find all these products on our website, www.ARWMisure.it. For any further information or clarification, please refer to the end credits of this video. Thank you for your attention and see you next time.
you.